Ladies and gentlemen, esteemed colleagues, fellow researchers and honored guests. It is an honor to stand before you today at the prestigious ICECO's 2024 conference. My name is Arif Ibrahim Wooler, and I am thrilled to share our research on balancing risk, cost, and performance in operational planning under budget constraints. This work would not have been possible without the invaluable support of my esteemed colleagues, Bayu Sararso and Ferry G, who have been instrumental in shaping this research. In today's interconnected world, the decisions we make as individuals and organizations often involve a delicate balancing act between risk, cost, and performance. Let's consider a familiar scenario. Traveling from Jakarta to Semarang, we could choose to fly, taking the fastest but most expensive route. Alternatively, we could opt for a train or car, each with varying degrees of cost, convenience, and risk. This seemingly simple example mirrors the complexities faced by businesses and industries worldwide. Just as personal preferences influence our travel choices, organizational decisions are shaped by factors like budget constraints, the desire for performance, risk tolerance, and time sensitivity.
This picture was created from insights and experiences shared by hundreds of IAM members, representing a huge range of organizations and industries. Before they start the journey, most organizations find themselves making asset-related decisions reactively and in isolation. Cost, risk, and performance all need to be factored in. But each factor has its own team, its own specialism, and its own language, and no one seems to be able to translate between them. Decisions are taken based on the limited information that's available locally, and therefore tend to be very reactive. Here's a typical example. Something happens to an asset that causes a major disruption. This could be anything: a material failure, an environmental incident, a technical fault. Amidst the panic, there's excitement because those first on the scene feel pride in their ability to handle the crisis, and heroic behavior is something the culture rewards. In the immediate aftermath, the risk tribe homes in on the incident and tries to eliminate the possibility of it happening elsewhere. Because the causes are unknown, they make sweeping decisions, which the engineering tribe across the way sees as an overreaction. Unfortunately, there doesn't seem to be any way of translating the engineer's experience and intuitions into a risk model that the risk people will understand. The maintenance people are upset because they'd been warning about this for years. Now customers start leaving as service declines, with direct financial consequences. As cash dries up, finance start delaying capital investment, which leads indirectly to further incidents, and round we go again. Notice some of the things going on here. Everyone's making good decisions based on their own limited understanding of the world. Although this stage may be imperfect, just having a system that brings people together to make decisions will inevitably yield quick wins, providing impetus for further investment in transformation activities. Unfortunately, these activities can't all happen at once. So there need to be winners and losers, as interventions are prioritized according to what will yield the greatest benefits for the whole. But in a way, this is the shape of things to come. Until individual teams are prepared to accept that the right decision for the overall business may be the wrong decision for them locally, optimal asset management decisions will not be possible.
This is where a framework for integrated decision-making comes into play. By fostering a fluid flow of insights and information, organizations can break down barriers and ensure that decisions are well-informed and aligned with strategic goals.
The formal policies and management system provide a framework for integrated decision-making, but these organizations are very fluid in how insights and information flow from team to team.
In this slide, we delve into the heart of our study conducted in collaboration with PT PLN Persero, a prominent electric company in Indonesia. Our focus was on enhancing their risk mitigation strategies, specifically targeting 65 non-routine projects with a combined value of approximately 14 billion rupiah. The graph you see here illustrates the comparison between two prioritization methods, manual ranking and the TOPSIS method. Manual ranking, as the name suggests, involves a subjective assessment of project priorities based on their start dates. On the other hand, the TOPSIS method, a multi-criteria decision analysis technique, offers a more systematic and objective approach. The x-axis represents the project ranking numbers, while the y-axis shows the cumulative score for each project based on various criteria such as budget, relevance to key performance indicators (KPIs), asset reliability significance, risk reduction level, and implementation time. The blue line depicts the cumulative score using manual ranking, while the orange line represents the cumulative score using the TOPSIS method. The graph clearly reveals that the TOPSIS method consistently yields a higher cumulative score across all projects ranking. This indicates that the TOPSIS method is more effective in identifying and prioritizing projects that offer the greatest potential benefits in terms of risk mitigation and overall performance improvement. By adopting the TOPSIS method, PT PLN Persero can make data-driven decisions, ensuring that their resources are allocated to projects that have the most significant impact on their operational resilience and strategic objectives. This approach not only optimizes risk mitigation efforts but also maximizes the return on investment for the company. In this slide, we delve into the methodology employed in our study to enhance the decision-making process for risk mitigation projects at PT PLN Persero. Recognizing the multifaceted nature of these projects, we incorporated a comprehensive set of criteria to evaluate and prioritize them effectively. The criteria we considered encompass a range of factors crucial for holistic decision-making. These include budget, the financial resources allocated to each project, ensuring alignment with the company's budgetary constraints. Relevance to KPI, the degree to which a project contributes to the achievement of key performance indicators, aligning risk mitigation efforts with strategic goals. Asset reliability significance, the impact of a project on the reliability and performance of critical assets, safeguarding operational continuity. Risk reduction level, the extent to which a project mitigates potential risks, quantifying the effectiveness of risk reduction measures. Implementation time, the estimated duration required to complete a project, facilitating efficient resource allocation and timely risk mitigation. To ensure the accuracy and reliability of our analysis, we conducted a thorough data cleansing and preparation process using Tableau Prep, a powerful data preparation tool. This involved identifying and rectifying inconsistencies, errors, and missing values in the dataset, ensuring a solid foundation for subsequent analysis. The culmination of our efforts is a visually intuitive dashboard created using Tableau Desktop, a leading data visualization platform. This dashboard serves as a centralized hub for decision makers, providing them with a comprehensive overview of the risk mitigation landscape. By integrating the diverse criteria and presenting the data in a user-friendly format, the dashboard empowers stakeholders to make informed decisions that balance risk, cost, and performance considerations. In this slide, we present the results of our analysis comparing two methods for prioritizing risk mitigation projects at PT PLN Persero. Manual ranking based on existing strategies, highlighted in blue, and the TOPSIS method, a multi-criteria decision analysis technique, highlighted in orange. The table displays the ranking of 65 risk mitigation projects using both methods. The projects are listed in the first column, followed by their scores for various criteria such as budget, relevance to key performance indicators, KPIs, asset reliability significance, risk reduction level, and implementation time. These scores are used to calculate the cumulative score for each project under both ranking methods. The table reveals significant differences in project rankings between the two methods. For instance, the project ranked first using the existing strategy is ranked 13th using the TOPSIS method, while the project ranked first using TOPSIS is ranked at 64th. The cumulative score, shown in the last two columns, reflects the overall criteria score of each project based on the respective ranking method. The TOPSIS method consistently yields a higher cumulative score across all projects ranking, indicating its superior effectiveness in identifying and prioritizing projects with the greatest potential benefits. These findings underscore the limitations on existing strategies for prioritization, which may not consider all relevant factors. The TOPSIS method, by incorporating multiple criteria, offers a more nuanced and comprehensive approach to risk mitigation project prioritization, ensuring that resources are allocated to projects with the highest potential impact on overall performance and risk reduction.
This picture was created from insights and experiences shared by hundreds of IAM members, representing a huge range of organizations and industries.
A key finding of this study is the substantial discrepancies identified between project rankings derived from the TOPSIS method and the actual project execution outcomes. Notably, the TOPSIS approach led to a significant higher cumulative criteria score of projects compared to the original project execution. This underscores TOPSIS as a valuable decision-making tool for optimizing resource allocation and enhancing risk management practices within electric companies. The implications of this study extend beyond the specific case of PLN. The methodology and findings can be adapted and applied to other electric companies and diverse operational contexts, including government agencies, oil and gas companies, factories and telecommunication providers, etc. By integrating risk, cost, and performance considerations, the TOPSIS method offers a robust framework for navigating complex decision-making scenarios and ensuring efficient resource utilization.